All right, welcome to this year's graphics course. My name is Wolfgang Hurst. I'm the instructor for this year's course. Yeah. So today I will first talk a little bit about some organizational stuff. Sorry. I put everything on the website yesterday, but there is a lot of stuff like formal things, and especially for the grading, what kind of tests we have and how the grading is going to be done. So I will repeat all of this today, but you also find this information on the website. And then in the second part, I will talk a little bit about some basics, some introduction stuff, so you can go to the tutorials and to the practicals, which actually start already today and not like it is set in the Osiris system on Thursday. So already today after the lecture there are the first tutorials and the first practicals. And you find the group for which you've been assigned to on the website as well, on the Computer Science Department's website. Good. So as I said, my name is Wolfgang Hurst. I'm a member of the Multimedia and Geometry group in the Computer Science Department. So we're part of the Game and Media Technology program, the master program Game and Media Technology. And as I said, I'm a member of the Multimedia and Geometry group, and I'm working mostly in multimedia, so I don't really have a computer graphics background. I'm not doing really much work in computer graphics, although what I do in multimedia also involves obviously a lot of computer graphics, because computer graphics is an important part of multimedia. But I'm not really a computer graphics expert, which I think is actually might be an advantage for an introduction course, because often when you have at least when I was a student, it often happened to me that you're in an introduction class from a real expert in that area, and they use the vocabulary, the terminology in a way that was quite confusing for me, because it was all new for me, but for them it was something that they do every day, so they somehow lost, I think, the touch to the people who have no experience in that area. So not being an expert might actually be in that area might actually be an advantage for you. So, but don't worry, I have enough knowledge about computer graphics to teach this course. I'm doing it for the third time now. Good. So, yeah, since I normally you start a computer graphics class by showing some nice computer graphics, but since I am a multimedia guy and not a computer graphics guy, I usually show some multimedia. So I just usually start this class by showing a little video. So this the beginning is in German, but then it's basically about a German Coast Guard who is new at his job, so he gets an introduction from his boss, and then you will see what happens. So it switches to English then later somehow.
Das hier ist mein Sektor. Das hier ist das wichtigste Gerät des Küstenwächters. Das Gerät und das Gerät. Überlebensradar.
Can you hear it?
Mayday, Mayday. Hello, can you hear us? Can you hear us? Can you... Over. We are sinking. We are sinking.
Hello? This is the German Coast Guard.
We are sinking. We're sinking.
What are you thinking about?
Sorry, I don't know why the speakers are not really working. Good. So, sorry for that. It's always in the first class you always get a little confused with all the new stuff, but that usually improves by the second or third time. So in case you haven't realized it, I'm not speaking Dutch. This course will be taught in English. The major reason for this is that I'm not Dutch. I'm from Germany. I came here in November 2007. So meanwhile, I took 2 Dutch classes, but still it's not really very good. I start understanding works reasonably well, but if I speak Dutch, it's usually very painful for the people who have to listen to it. So it's trust me, it's better for you if I do this in English. I hope it's not a problem for anyone. If you have a problem with the language, just let me know, and then we will see how we can figure that out. So you should not have a disadvantage just because I'm not able to speak your language. But there are actually also other reasons why we teach this course in Dutch, not in Dutch, but in English. Two of the teaching assistants also don't speak Dutch. They are from Indonesia and Germany. There are also, I think, advantages for you because all the material, the textbook, is in English. So I think it's easier probably to read the textbook in English and also have the lecture in English than switch between two languages because all the terminology is also in English. Another reason is that although the bachelor program is in Dutch, the master program is usually in English. And I personally think it's a good idea to, even at the bachelor level, have at least 1 or 2 lectures in English because it just makes the transition from the bachelor to the master program easier because you don't, it's easier to adapt to the language when you already have experience in listening to English lectures. In fact, also the guy who taught this course before me was René van Oostrom. He was Dutch, but he also taught the course in English. I don't know what his reasons was. I think one of the reasons for him was also that there are a couple of people from the master program who are also attending this course, although it's a bachelor course, but they come from a different university, so they don't have had computer graphics there. So they have to take this course, and some of them don't speak Dutch because the master program is in English. All right, so yeah. So it will be in English. If you have problems with this, just let me know. The lectures will be Monday and Wednesday from 9 till 10:45. I didn't write down the room here, but I guess you all know where it is. We will basically use one textbook. There are a few chapters where I will do it a little bit different than the textbook, but I put the slides on the web, so usually that shouldn't be a problem. In a few cases, I will also use some additional material, which will also be posted on the web. The textbook is Fundamentals of Computer Graphics from Peter Shirley. It's the current edition is the second edition. If you have the first one, it's not really much of a problem. You don't have to get a new one. There are just some slight changes. There is an additional chapter which we will not cover in this lecture anyhow, and all the other stuff pretty much stayed the same. At least the stuff that we're using here. It's just because of this new chapter, some of the numbers of the chapters and the pages have changed a little bit, but that should be easy to figure out. Good, so there will be 12 lectures. I will show you the schedule later, and it's also on the website. In case you wondered why I'm wearing this weird microphone here, I'm recording the lectures and put the recordings online, so you can afterwards download them and listen to them again. So I'm recording the audio and also do a screen capture of what I have on what you see here on the data projector. It's also why I'm using this graphics tablet, so I can write here and it's also recorded. And also I will put the slides with the annotations that I make during the lecture online after the lecture, so you can also download it, so you don't have to copy what I'm writing here, so you can just download it and print it or look at it on your computer. Usually the recordings will be available within a day. At the beginning, it always takes some time to set up, so there might be some delays at the beginning, especially today because I have to go to a PhD defense in the afternoon, so I will not be able to finish it today, but usually after the first week, it's usually online on the next day. Important thing is that you keep in mind that I'm doing this, but I'm not really putting much effort into it. So it might be always, if you use something like you saw with the microphone, if you use technology, it always can fail. So far, fortunately, we never had, we had some technical problems in the previous lectures, but fortunately, we never had the situation that I gave a class and afterwards the recording was lost or it didn't record at all. Which was fortunate, but obviously that makes it more likely that it will happen sometime soon, sometimes in the future. And since it hasn't happened yet, the chances that it will happen this year are probably bigger. So the point here is just don't rely on this. Like I know a lot of students stay at home because they prefer to watch the lectures at home for several reasons. That's fine with me. I'm not usually forcing the people to come to my class, but it's fine with me. But don't come later if for whatever reasons there is one lecture not recorded. Don't come later and complain and say, well, I didn't come because I thought it will be recorded and I can watch it online and now it's not here. So then this is basically your problem. The other thing I like to mention is that you should really think about carefully how you take advantage of this, because there's always the risk that if you know, okay, it's going to be recorded anyhow, so I'm not going today, I watch it online, and then you don't have time this day, so you get behind, and then suddenly you're so much behind from the lecture that it's very difficult to catch up. So what I usually recommend is for the people who decide not to go to the lecture, but to listen to the recordings instead, have a schedule and watch them regularly. My recommendation is to go at least to the tutorials, because that somehow forces you to keep up with the content. I think the major difficulties with this class is not that much the content, but it is that there is a lot of content here. So for the exams, you have to know a lot of things, and if you don't catch up with the stuff in time, it will be very hard for you at the end to make up for this shortly before the exam. So, but obviously I don't want to encourage anyone to skip the lectures and just listen to the recordings. The major idea of these recordings is more that you have a chance, if there is a part that you haven't understood or so, that you can repeat it when you do, for example, the exercises or when you prepare for your exam. So the major idea of this is not that you can all stay home and sleep a little longer on Monday morning, but that you have some additional material that you can use for preparation and for learning. Good, but it's your choice on how you take advantage of this. Or if you don't take advantage of this at all. Good, I already said there will be tutorials or exercises and practicals. The tutorials will be supervised by 2 or 1 teaching assistant. The major teaching assistant is Robitan, a colleague of mine. And in the beginning, so there are 2 groups, which is why at the beginning also Saskia Kronewegen will be a teaching assistant for the tutorials. The tutorials are voluntary, so you're not forced to go there, but I highly recommend it, of course, because the exercise, the thing is, you usually learn more by doing some stuff instead of just listening and reading. Of course, the listening in the lecture and the reading of the book is very important, but usually you really understand the content only by doing it. And also, 2/3 of your grade will be based on the exams, so it will be based on exercises. So doing exercises to practice for the exam is obviously a very good idea. So I highly recommend that you go there. The tutorials are directly after the lecture. But experience shows that because you're not forced to go there, that after a while the number of students drop in the tutorials, which is why usually we say we move everyone to one room and just have one teaching assistant there. This has the advantage that a second teaching assistant can go to the practicals, because this year we only have 4 teaching assistants, which means 2 for the practicals, 2 for the tutorials. But usually there are more questions for the practicals and also explaining some stuff in the programming when you have you're debugging something, or so usually it takes longer. So the supervision there is more intensive, which is why we usually say that after a while we then just say, okay, 1 teaching assistant is enough, and then we move it to 1 room. I don't know which of the 2 is the bigger one. So after a while, we will just move it to 1 room, and then you will just have 1 teaching assistant, which, as experience shows, is usually enough for the tutorials. So how it works for the tutorials and also for the practicals is that you have each week there will be a new exercise sheet. The first one I put it online yesterday, so you can go to the website, download it, and then you go to the tutorial, and then you basically do the exercises. So there is it's not like it's a teaching like here where someone is explaining something to you. So you basically sit there and do the exercises, and if you have a question, the teaching assistant comes to you and you can ask him, and then he can explain it to you. If it turns out that it is a problem that everyone has, then he might go to the blackboard and explain something, but usually it's more an individual thing that you sit there and do the exercise. If you don't have any questions at all, and then you will have will probably not talk to the teaching assistant at all. If you have a lot of questions, he will try to help you. Good. I usually put some solutions, or at least sketches of solutions and hints for the solutions online, but I usually do this only before the exam, shortly before the exam, because experience also showed if I'm doing it now or shortly after the tutorial, the numbers of people who attend them will drop even more. And as I said, I think it's very important that you go there and do the exercise, which is why I will try to do everything, besides forcing you to go there, try to do everything to motivate you to do it. Good, so there will be 7 exercises. I will show you the schedule later together with the lecture schedule. In addition to this, there are the programming labs. So on the on the computer department side, you see that you've been assigned to a group, and there are 2. So there are 4 groups. 2 of them have their tutorial on Monday, and their programming exercises on the programming labs on Wednesday, and for the other 2 groups it's just the other way around. So for the tutorials we also have 2 teaching assistants. One is Corain Kammerling, the other is Martin Abink, and later Saskia will also join them. So we have 2 or 3 student teaching assistants. Here it's also so that after a while the number of people going there drops, which because some people they like to rather do the programming at home or work at another time. So after a while we sometimes also move it to one room. That has the advantage that all teaching assistants can be there, so it's easier to supervise you. But then what we usually do is because here we have you depend on the number of computers. So what we usually do is we fill the first room, and when the first room is full, then the people go to the other room. So if there are not more people than we can fit in one room, then all teaching assistants can stay there, and it's easier for you. They also start today. That was basically my mistake, that this was not probably announced in the Osiris system. So I apologize for that, but the consequences are not really much for you, because there is no other way to start it next week. If we would start it next week, then 2 of the groups will have 1 tutorial less before the exam, because there are only 3 weeks and I cannot create additional time. The scheduling that was provided from the administration this year is a little unfortunate. It's very dense this year before the midterm exam, and that was set by them. I cannot change that. But in case you already made plans for later and don't have time to go to tutorials or the practicals today, it's not that critical, because as I said, they are voluntarily anyhow. And if you don't do the tutorials this week, you can also do it next week and ask the teaching assistants about the first questions about the first exercise sheet also next week. Obviously, the only problem is, as I said, you risk that after a while you're not able to catch up, because the material becomes getting more and more. Good. So for the programming labs, there are 2 assignments which will be part of your grading. The deadline one is in the middle of the term, which is shortly, I think, after the midterm exam, and the other is shortly before the final exam, or the other way around. I'm not sure yet, but we will see at the schedule later. There are 2 assignments, but they are actually part of one larger assignment. So it's basically one big assignment, but we split it in 2 parts. So it makes the grading easier, and also gives you some feedback in the middle, and also puts some pressure on you to have a deadline, because if we just have one assignment, then usually 90% of the students do a little work in the first week and then nothing before like 1 or 2 weeks before the final deadline. So this is why we split it in 2 parts. Just be aware of it, that in the second part you have to work with the code that you produce in the first part, which is why you should do it quite well. The grading changed a little bit compared to last year. Also on the website there was this old form till yesterday. I changed that. it is now the first part only counts 0.4 and the second counts 0.6. And the reason is that we did some changes compared to last year. The idea of the programming exercises is that there is a mandatory part, which gives you, last year the idea was it gives you maximum a grade of 8.0. And if you want to have a better grade, you have to do some extra work. And this is not, we give you some hints on what you can do, but this is basically up to you, whereas the mandatory part is strictly outlined what the steps that you have to do. I saw that, but my impression was that a lot of people had problem doing this extra part in the first part of the assignment because they didn't have that much experience, and the impression was that while after they did the second part of the assignment, they had much more. The lecture was more. They had more content in the lecture, and they had more programming experience, so they were much better in doing this. Additional part, this extra part where there are no such strict guidelines, which is why I thought I split it basically in 3 parts. We have a first mandatory part, which is P1. We have a second mandatory part, which is P2. And then we have an extra part, which is also part of P2, which is why you have this weird grading here. So in the rule now is that you have, let me check this here so I don't make a mistake. So you have P1 is mandatory, and you get maximum grade for this of 10.0 when you do everything fine. P2 has a mandatory part where you can get a maximum of 7.0 points or grade, and an extra part where you can do whatever you want, as long as it's related to the assignment, where you can get a maximum of 3 extra points. So it looks like the mandatory part of P2 isn't really that much, but because of the different weighting, you see it works out that it's basically like last year. You have you can get around 8 credits for the mandatory part and 1.8 credits for this this extra part. So if you look at it, the maximum is for P1 0.4 times 10. So that is maximum credit of 4.0 for the total here, for the total programming credit. Plus for P2 you have 0.6 times maximum 7 plus maximum 3, and that here is 4.2, and that here comes down to 1.8. So you see here you get around 8 maximum and around 2 here. So this is just to explain you, because you might wonder why we came up with this different weighting. And also P2 is, because of the extra part, larger, or it's more programming to do than for P1. So be aware of this, but also P2 builds on P1, which is why it's important to do the first assignment very carefully. But also P2 is larger than the first assignment, so if you have already finished the first one, you're welcome to start with the second one even before the deadline. The first one is online now. The second one I will put it online next week. I just have to do some final checks with it with the teaching assistant, and then by the end of the week that should be done. So next week probably the second assignment will also be online. Good. Some formal stuff. The programming labs have to be done in teamwork. That's a tradition with this course, and the reason is basically that, or the goal of this is that you learn teamwork, because in practice you will hardly even work alone. So it's always, usually you always work in a team with some others together. And the purpose of this is basically to learn this. So the assignments have to be done in teams of 2. Last year we handled this quite flexibly, and it turned out that a lot of people took advantage of this, which is why this year we will be a little stricter. So we introduced a new rule, which is basically if you do not do it in a team but turn in your assignment alone, then we will, in the end, you will get a downgrade of 1.0, some sort of a punishment. It's not a punishment, it's encouragement not to do it, basically. There are exceptions, of course, which I will address later. So how it works is basically you just pick yourself a partner. In case you have problems finding a partner, then talk to your teaching assistants from the group you are assigned to, because if all people who don't have a partner go to a teaching assistant, we know who is still looking for a partner and we can bring the people together. In case you have a partner who was assigned to a different group, then just team up and go to whatever group you want to. In general, we handle this very flexibly with the groups. Formally, you are assigned to a group, but if you think, I want to have material rather on Monday and the practicals on Thursday, but I was assigned to it in the other way around, then usually it doesn't matter as long as the people distribute reasonably well. If it turns out that like 90% are going to the Monday tutorials and only 10 to the Thursday tutorials, then we have a problem and we have to do something about it. But otherwise, if it splits equally, more or less equally, that's fine with us. I don't think there will be any restrictions. So if you have a partner from another group, just go to one of the tutorials, just go to the one which you want to. The programming assignments didn't really change much from last year because I did some changes where we saw that there are problems. For example, with the assignment, we changed it in a way which I think is better for you, that you have the extras at the end and not already at the beginning, because I think it will result in better grades for you and that you learn the stuff better. But the major tasks pretty much stayed the same, but we want you're not allowed to use last year's code from other people or other code that you find on the internet and just copy and paste. And there is a software to check these kind of things, and we will usually use this kind of software. And if we catch someone doing it, then we have to let him fail and we have to report him to the administration. I don't know what they're doing. So far, it fortunately hasn't happened. So I don't know what they're doing, but it's certainly not going to be nice. So yeah, this is just the rules. We have to report you and we have to let you fail when you do it. So just don't do it. Exceptions to these rules, alt code use and teamwork is for the students who did this course last year. Because the programming exercise didn't change much, it would make no sense to have someone who did it already last year doing it with someone who does it this year, because he has a certain advantage. So if you're basically free to decide if you do it in a team or do it alone. If you do it in a team with someone who hasn't done it last year, then you cannot use your old code. If you do it in a team with someone who has also done it last year, obviously you can reuse your code, or you can do it alone and just not reuse your code. So it's basically up to you. Only if you team up with someone who hasn't done it last year, then you should do it again and not just copy your old code, because then your partner will not learn anything. Good. There are very few situations where there are also other exceptions will be made, but as I said, we will handle this much stricter here this year, because last year some students took advantage of it. But if you're in doubt, then you can always contact me. But do it early, please. So if you will contact me like a week before the deadline and say, well, I haven't found a partner, can I do it alone? You will, this rule will almost certainly be applied. So in general, I'm usually very relaxed when it comes to these rules. I basically make the rules here very strict, so I'm on the safe side. If someone comes later and complains, I can always say here, that's the rule, and that's how I'm going to handle it. In a lot of situations, I handle it rather flexible, but unless I have the impression some students take advantage of it, this is something that I really hate, and then I will be strict. So the more you rely on me handling these rules flexible, the more likely it is that I will not do it. So just try to stick to the rules, and then we can handle the exceptions pretty flexible. Good. So the practicals go into your final grade, and to 1/3, and 2/3 of your final grade will be the exams. There will be 2 exams, a midterm exam on September 28th and a final exam on November 2nd. The first part will mostly cover lectures 1 till 5 and the first 3 tutorials. The second part will cover the rest of the lecture and also some information from the first lectures, of course, but the focus will be on the second part. They are equally rated, so each counts 50% for your final grade for the exams. If you did the course last year, the exercise will of course change, and the grades from last year do not count, so you have to do it again. You have to participate in both exams. Of course, there are exceptions. If you get sick or so, then, or sometimes we have a situation that someone is going on an exchange or so and is not here in the week, then usually you are granted the permission to do the retakes instead. If you have such a situation, try to contact me before the exam. The rule is that if it's for the exam and you have a good reason, then you're obviously granted this exception. If it's after the exam, then I put a kind of statement there, then it's basically up to us to decide. So this is also a rule somehow to force you to do it as soon as possible if there is a situation. But of course, the best thing is if you come to both exams and pass them, then all these other rules that I'm specifying here are irrelevant for you. This is the data as it is right now. There might be changes, so always make sure that you check the website for final announcements. I will always put up-to-date important information on the website. On the first site there is a news section, so if there is something important, some important announcement about the lecture, then I usually will put it there. So it's probably a good idea to once a week or so check this first site, the first page of the website. Good, I already said the final grade will be a combination of your exam results and your practical results, 2/3 for the exam and for the written test and 1/3 for the programming assignment. The minimum grade to pass is at least 6 after rounding, so that basically means 5.5 will already result in you passing the course. But there are also two other rules, which is that you have to have at least 5 zeros before rounding to pass, to be allowed to pass the course. And the reason for this rule is that otherwise there is always this situation that some people say, well, I just do the exercise and don't do much for the practical course because for the practical part, because I'm so good in the exercise, in the theory, that I don't that I pass this course easily by that. But the point is, you should learn practical skills and theory in this course, which is why we have to force you to do both. So you see here, this is also a rule that we had to include because some people tried to take advantage of handling it more relaxed. In case you fail, but you have at least a 4, either in the practicals or in the exam, then you're allowed to do a retake. This is also something that I changed when I took over the course to make it actually easier for you. There are 2 retake exams. One covers is basically a retake for the midterm exam. The other is the retake for the final exam. And you can choose to either take both or take one of them, and it always replaces if it is better, then it replaces the grade from the respective exam or midterm exam. So if you do the retake for the midterm exam, you can replace or improve your grade for the midterm exam. If you take the retake for the final exam, you can improve these grades. Good, and the date for this is already set. It's December 21st. Good, but yeah, I hope that not many people will have to take advantage of this. Good. Yeah, as I said, there is a website where everything is specified. So this is let's just have a quick look at it. This is the entry page. And you see here, this is where I always post if there are some announcement. Usually there is not much here. It's only like now I announced that the first programming assignment is there. I put the oh no, that doesn't work. I put the slides and the annotated slides usually online after the lecture, and also the recordings. I do not announce this on the first page because you know that after the talk, after the class, like usually the next day, it is online. Here I also usually write down which part of the textbook are covered by the lecture. so you can, if you want to do some reading, you know which chapters are covered, or if we do it differently than in the lecture, than in the textbook, then it's also announced here. And if there is some additional material that is not in the textbook but I'm using in the course, then it's also posted here. Good. So for the schedule, as I said, it's very dense here. I don't know why they did it this year. Last year we had 1 week more before the midterm exam, which made it a little more flexible. So there is a group who has their tutorial on Monday. They will always have the tutorial directly after the lecture. So you see here, this year, the first tutorial is basically some general introduction and some of the stuff we cover today. The second one will cover the first 3 lectures. The third one will cover the lecture from lecture number 4 and number 5. So you see it's always shifted like half a week, but it's because the lecture is before the tutorials. You always will have all the material when you go to the lecture available at the tutorial. Good. And yeah, then there is the midterm exam at the end of September, also on Monday. Coverage, I already said this. Obviously, when there is an exam, there are no tutorials on Monday. There's also no tutorial on Thursday because there is no new material here. But the practicals take place, not on Monday, of course, because you're all supposed to go to the exam, but on Thursday, which is important because that's the last day before the deadline for the first programming assignment. So those of you who normally have a tutorial on Thursday are welcome to go to the programming assignments. I will tell all the 3 teaching assistants from the programming assignment to be there. So there are a lot of more people there to answer your questions if you have some last minute questions. Obviously, I always encourage you not to do it to wait till the very last minute, but to finish them early enough so you have time to ask your questions also earlier. Good. Then it will continue, and you see also always before the exam, I like to usually have 1 or 2 days where there is no lecture, so you have some time to prepare, because I don't think it's a good idea to have a lecture on Monday and then on Thursday you already have to write the exam about the content you just heard 2 days before. So I usually like to give you some time to prepare for this. Good. Yeah, and you see the deadline for the deadline for the first programming assignment is shortly after the midterm exam, and the deadline for the second assignment is shortly before the end term exam. That's just because of the scheduling, but that's also why you have here 2 days without a lecture, whereas here you only have 1 because the programming assignment is due later. Again, this is the situation as it is right now. There are always it's always a possibility that we have to change it, and then I will announce it on the first site here under the news section, and obviously also in the lecture. Good. Yeah, tutorials will be uploaded here. As I said, before the exam, I will also upload some solutions or sketches of the solution, some comments that should help you in preparing the exam. The programming assignment, I will talk about this later. What's that? Yeah. And here you see a summary of the exam. And not of the grading, how the grading is calculated, basically what I already told you. But here it is formally written again, so you can read it, because I know it's a lot of information now. And it looks a little confusing at the beginning. But if you're confused about this, just do everything and do it in the best possible way. Then you will have no problems. You don't have to understand all this. The exams will later also be posted here, but obviously they are not available yet. Good. All right. Good. So much about the formal stuff. So now let's start with the actual content of the lecture. And now is finally some time when you want to show some
And now an episode from Disney Pixar's Up.
Russell, what are you doing?
I'm making an official Wilderness Explorer snipe trap. And as soon as a snipe steps right... Help! Thanks again for saving my life, Mr. Fredrickson. And now for the perfect snipe bait. No animal in the entire universe can resist chocolate. Whoa! Help! It looks so chocolatey.
Russell, if you...
Maybe if I'm really quick.
Wait!
Oh. You want some?
Disney Pixar's Up in theaters May 29th and presented in Disney.
All right. So I'm not paid by them. Not making here advertisement for them, but this is basically just to show you some state-of-the-art computer graphics as a little introduction to this. Let's sit with the microphone here. A little introduction to computer graphics. So we'll talk a little bit about now what computer graphics is, and then later I will start with some basic stuff, so you have some materials for the exercise and also for the programming assignments. Good. So yeah, what is computer graphics? If you look at our textbook, then it says computer graphics describes any use of computers to create or manipulate images. Now, the important sentence here is to create images. That is, we have an idea of something that we want to show, like a virtual world or some world we have in our mind, and we want to create an image of that world on the computer from a specific view. For example, in this movie that you saw, or in the image that you see here from the movie, we have this world where we have these two characters, we have the background, and then we create this on the screen. And this is very related to other fields, but it is different, for example, from image processing and computer vision. Just to make it a little clearer what the main focus of computer graphics is, because usually you think like everything I'm seeing on the computer is basically some sort of graphic. So if I take a picture with my camera, with my digital camera, and put it on the computer, is that computer graphic or not? In some way, it is a computer graphic when you have it on your computer, but it's not what you usually think of when you talk about computer graphics, and it's not what is taught as part of the discipline computer graphics, because that is more part of image processing. Because in image processing, you usually take an existing image as an input and perform some action on it. This can be an image from digital camera that you just show, or you can do some apply some compression algorithms when you store it. You can do some noise reduction, some sharpening. For example, one of the teaching assistants, Hobby Tan from the tutorials, he's a colleague of mine, and he's doing research in image processing. He has developed some algorithms for fog removal. So you take a picture of a landscape where there is fog, and then he's automatically processing the image so the fog is removed and you can see much clearer. So these are all the kind of things that you can do with images that are considered as part of the area or the discipline image processing. Obviously, the border between image processing and computer graphics is not really strict, because the quote also says computers to create and manipulate images, but the point is that in image processing we usually take a real image, more like a photo, whereas in computer graphics we create an image in the first place and then manipulate it. So the borderline is obviously very not strict. For example, if I take this image here and make it sharper, change the color, or do some things, is this image processing or is it computer graphics? That's hard to say. So there are these two areas usually certainly overlap, but they are not identical. The same is true for computer vision. Computer vision is basically all kinds of approaches to that try to get an understanding from an image of the real world. So usually of the real world. So, for example, this includes everything like face tracking. When you do face or face recognition, you have a webcam and you recognize faces, or you track the faces when a person moves, or image analysis as part of video analysis, when you have a video and when you segment it in different scenes. For example, when there is a camera cut and you want to automatically identify this, then you do some analysis of the images to identify this camera cut, and this is usually done in the area of computer vision. So it's in one way like the opposite of computer graphics. In computer graphics, we want to create a real image or a realistic image of an artificial world, whereas in computer vision we usually want to create an abstract representation of or get some abstract information of a real image from the real world. Good. But as I said, those areas are closely related, and the same is true for other areas, for example, interfaces and human-computer interaction, because most of computer graphics today is very interactive, so we hardly look at just images. So we also have movies, or we also are able to manipulate movies. We have computer games where we walk through different worlds, so we have some interaction here, which is why usually when you study human-computer interaction or interfaces, then you usually also have to do a lot in computer graphics. Other areas are virtual reality, visualization, and so on. So there are many more areas where computer graphics is important and involved in. And I'm also saying this because, as I said, I'm not doing computer graphics research myself, but for example, I'm working a lot in interaction and human-computer interaction. So if you're interested in a bachelor thesis or a student project in computer graphics, you can also contact us. We also have a lot of very interesting topics in relation to computer graphics, even if we're not doing explicit research in computer graphics. Like I said, my colleague Albitan is doing image processing, which is also quite related to this. So if you like this course, you will probably also like what he's doing. Good. So now I talked a lot about what computer graphics is not, but what is computer graphics? So there are certain aspects, but mostly a lot of the work and mostly everything that we cover in this lecture is related to 3D graphics. So the idea is to create an image of a virtual world or virtual scene of some graphical 3D objects from a specific view on a computer screen or a graphics device, usually a raster display like we have it on the normal computers. So we have a complex 3D scene, and we want to show a 2D image of that 3D scene on the screen. And there are so there are also 2D graphics also exist, of course, but this is not the major focus of this course because they are much easier. So we will basically focus on 3D graphics and how we can create an image on a 2D screen of a 3D world or a 3D scene. And there are two major tasks that are involved in this. First of all, it's the modeling, which is basically the generation of this 3D scene. And the second part is the rendering, which is basically the transfer of the 3D scene on the 2D screen. So modeling is basically creating a description of a 3D world in a language that the computer can understand. So basically we create a mathematical description of our 3D world. And this process is usually called modeling. There will not be much talk about modeling here in this class because it would make it it would be too much. So we will only talk about the basics here. But there is a class in the master program on 3D modeling. So if you're interested in that, you can also go there and get some information there or later in your studies. So with modeling, we describe a 3D world, but the image on a computer screen is a raster display. So we basically have a matrix of pixels or single dots. And but when we describe these pixels or dots, we describe these objects, we usually don't describe the pixels on the screen when we are modeling when we're creating this image, but we describe rather the object. So we have a person like in the movie you just saw, or a circle, and we want to create that, and we do not internally calculate which each single pixel of the circle, but we represent the circle in an abstract representation because it makes handling much easier. Because if we have an abstract representation, for example, for a circle, we need a position, basically, for example, the center of the circle, and we need the radius. So these are just two parameters that allow us to describe the circle perfectly. Whereas if we store the pixel, we have to store all the pixels individually, and also we cannot do calculations with it. For example, if we have a circle and we want to display the same circle at another position, we just have to change one value, which is the center, and then we can create easily a copy of the circle. Whereas if we have the pixels here, we have to copying or scaling and other operations are not that easily, cannot that easily be done, which is why we're dealing with this abstract representation, which is the process of modeling. Now, but when we want to create the image, when we want to see it on the screen, then we're dealing with pixels. So we have to address this question on how we bring this abstract representation to a 2D of the 3D model to the actual screen, that is, to the actual pixel. So we have to decide for each pixel what color it is and how what object it belongs to and what it represents. And this process is usually called rendering. That's a general term that is often used every time when in any context where you have an abstract description that you want to represent in actual pixels on the screen. So for example, also when you have a web browser, the process of taking the HTML and really showing it on the website is also called rendering, because the HTML is an abstract description of the text, and what you see on the screen are basically just pixels, and this process is called also rendering. In computer graphics, rendering is of course the process of taking the 3D representation of the objects or the scene that we have modeled to transforming this to a 2D raster screen or graphics bitmap. A bitmap is another term that is often used in this context, or basically a matrix of pixels. But we're not only just taking the objects and coloring the pixels based on the object description from the color, because that would not create a realistic image. But we also have to consider the color object, we have to consider the lighting, we have to consider shadows, we have to consider how different objects influence each other. So if there is a light and there is someone standing in between, then it changes the lighting of the other person. So there are a lot of things that we have to consider based on when we want to do a realistic modeling, and these are usually called shading. So in the book, shading is described informally as painting the surface with light. So it's basically all techniques that add some depth to this 2D image of the 3D models by considering things such as light, the characteristics of the surface, reflections, shadows. So shadows are part of shading, but don't confuse shading with shadows. That's something different, because shading is basically everything involved, and this is part of the rendering process. So the rendering process is basically first bring the 3D model to a 2D representation and color, put the perfect lighting and coloring on those objects, which is the shading. Good. Another area of computer graphics is animation, obviously, which is not covered in this course because, again, it would make too much content. So animation is basically adds a temporal component to this, which is for an animation for a movie, you also have a sequence of single images, but because you have this sequence, there are also other things that change. So for example, if you just create single images and then put them next to each other, you might have artifacts from objects that are moving. So there are a lot of new things that come in that you have to consider that come into play when you're dealing with animations compared to still 2D images, which is what we'll cover here in this lecture. Good. Yeah, so this is what we study. So the question now is, why do we study it? You saw that computer graphics, I already said that computer graphics is involved in a lot of areas, and also it is there are a lot of applications for computer graphics. So for example, this here are all more entertainment or leisure applications. You already saw a movie computer graphics. The movie industry is very big for computer animated movies, but also for traditional movies which use special effects. Another area is virtual reality, which can be leisure and entertainment, but can also have serious applications like simulation, for example. Firefighter training is a typical example of flight simulation training for pilots, which can be, again, a serious application, like in a simulation game for training, but can also be like a computer game, a leisure application. gaming is certainly an important area of computer graphics. We have this gaming and media technology program here, master program, where part of the program is mostly about computer games, because computer games is a really big market. There are studies that say that in a few years the money that is made with computer games will be larger than the money that is made with movies and the music industry combined. So you see that there is a huge market for it, which also means for you there are a lot of jobs for it, which means that's a good motivation to learn something about computer graphics. Now, information visualization, I also put this here in applications, but it's a little, you can also consider this an application, but you can also consider this more of a separate field. In this context, it's important to know that for computer graphics, we're basically dealing with the computational aspects of creating this image. We're not dealing with things that's such aesthetics and image composition and things like that. So this is more the art part of it. We're looking more into the technical stuff. And in information visualization, what is usually the goal is, or the question is, how to represent data to get a better insight into it. So obviously computer graphics and the technical aspect on how to present large amount of information visually is important for computer graphics, but it is not the only aspect of it. Good. So we know now what we will do, why we will do it. The question now is how we are going to do it. There are two like philosophies when you look at how people teach computer graphics, or if you look at basic introduction textbooks about computer graphics, you will realize that there are basically two approaches. One is the first one is, which is the one that we use here in this course, is to teach the basics and the backgrounds, and the other is to teach more the applications and the libraries and the programming. So there are, usually when you do graphics programming, you use a graphics API. Like common examples are OpenGL is probably the most popular one. From Microsoft you have DirectX, or you have Java 3D, which is a graphics library for Java. So that's what most of the people do when they program. So for example, if you program computer graphics and you want to draw a line, you usually use some sort of graphics API, and then there is a function, and then you say draw a line from here to here, and then it draws the line. You don't really draw each pixel and calculate each pixel and say, okay, this pixel is part of a line, this I color black, and the next one is not part of the line, I color it white. So what you usually do is just take a function, take a command. Whereas we teach more choose more the other way. We teach the basics and the background, which is basically deciding on which pixel we have to put a color in and which pixel we have to leave out when we want to draw a line. And now, there are different arguments why you choose one approach over the other. A lot of people, when they are in this course, or some people always are disappointed that they say, well, I have an introduction class on graphics now, but I never even programmed OpenGL once. Whereas they also argue that, well, in practice, I will never program a function to draw a line. I will use a function from an existing graphics API. But the reason why we decided to do this is that I think also it's a tradition from this course. So the guy who taught it before also did it this way, and I think it's good. It's important that to consider that we're at the university. So we're from when you get your degree later and you start working, people do not hire, when they hire someone from a university, they do not hire someone who just had a programming training experience, but they want someone who has a larger background and also is able to adapt to different graphics API. So and that usually is easier for you when you know the background. So even if you do not use not to program a function later that draws this line. Knowing how this function that you call from the graphics API works will make it easier for you and will make it easier for you to adapt to new programming environments. So this is why we think it's better to teach the basics here. So some of you might be disappointed by this, but yeah, I can't help it. Good. Yeah, so we will use this approach. There is also a very nice side effect for this, that it's an elegant way to teach some of the math. Like when I studied, we had this mathematics class where they taught us all the mathematics, and then we had more practical classes. But the combination between why we learn this kind of math and where we use it in practice, or where it's relevant in practice, gets somehow lost in this, because we had this practical programming classes and we had the theory math classes, and they are not really related. Whereas here you will also teach a lot of math as part of this course, but it's always I find it's always nicer to have more of a connection between the theory and knowing why you have to know this to be aware of the theory and what in which parts of the practices it is relevant. So I personally think this is a nicer way. Good. I already said that there will a lot of parts that we miss, like animations. We'll also not talk about graphics, hardware, animation, interfaces, because the field is just too big to cover it in one course. So we will only do the very basics. That's also a thing that sometimes people are a little disappointed from this course. At the end, when I read the evaluations, there is always one or two people who say, well, I was disappointed because it only scratched the surface of everything but didn't go really deep into it. The problem is this is an introduction class, so there are also people here who have no pre-knowledge at all, and for them it's just a lot of material, and it's very difficult to come into it, which is why we just cannot do it other than just scratching the surface everywhere. So there are also always the one or two geeks here who are experienced graphics programmers who know a lot of stuff, and they are always disappointed that we're not going too much into the details here, but scratch it on the surface. So for those, yeah, parts of the course might be boring, so I'm sorry for that, but there's nothing I can do about it. But if you get bored by the course, you're always welcome to do more work in the practicals. So this is why we have this extra part where you can do extra work. So there's no reason for you to complain. Good. So as I said, the two major areas that we will cover here in this course are modeling and rendering. Now I will talk a little bit about some basic methods, basically just a quick introduction into a few things. So you have some materials for the exercises, and also need to know some basics for the practical, so you can start right away. So today I will just give a little basic overview of a few things to get you into the topic, and then in the next lecture we'll go more into the details. So I already run over time, so let's just make a 15 minutes break and then we continue.